Welcome to the On My Workbench channel. This is part 2 of my project Solar Cop. In this part I will be talking about how I use the Outback Mate remote display for the FlexMax 80 charge controller as an interface to retrieve the data from the solar panels and from the FlexMax 80 charge controller. Unlike the EG4LL batteries that use the request and reply Modbus communications protocol as described in part 1, the Outback Mate remote display uses the RS-232 data communications protocol and continuously streams its data. As long as the Outback Mate is connected to the FlexMax 80 charge controller, it will continuously stream its data. Here's an example of what that data looks like. One issue that I had to overcome with using the Outback Mate is that its RS-232 port is optically isolated and is not powered from within the Outback Mate itself. It is powered from the device that is connected to it. I was using an RS-232 to USB adapter, and the adapter could not power the Outback Mate's RS-232 port, so I had to come up with a way of doing it myself. After researching it, I found out that I needed to put plus 12 volts on pin 4 and ground on pin 7 of the Outback Mate's DB9 RS-232 connector. This would supply the 12 volts and ground that was needed to power the Outback Mate's RS-232 port. So I built an adapter cable with a male DB9 connector on one end for the Mate and a female DB9 connector on the other end for the RS-232 to USB adapter. Pins 2, 3, and 5 on the male DB9 were wired straight through to pins 2, 3, and 5 on the female DB9. Pin 4 of the male DB9 was connected to plus 12 volt side of a 12 volt wall wart power supply, and pin 7 was connected to the negative side of the power supply. As luck would have it, after I built the power adapter, I found a place online called Right Hand Engineering with a drawing on how to build one, or you can buy one built from them. Links will be in the description. Once I got the adapter built and connected to the Outback Mate, I needed a way to display the data on a computer. So I used another software program that I have used for years. It's the development software for the basic stamp microcontroller modules. A link will be in the description. Now that I had the charge controller data streaming to the computer, I could compare the data that was displayed on the Outback Mate's display screen with the data that was streaming to the computer. I found and downloaded the Mate Serial Communications Guide in PDF from Outback Power's website. Links will be in the description. Figure 9 on page 11 of the PDF shows what each of the bytes of data in the string is supposed to represent. However, it appears that figure 9 in the PDF is wrong, and I had to redraw it to get the locations in the drawing to match up with the data that was displayed in the string. I called Outback Power Tech Support and was told that they did not offer any support for the Outback Mate. When I asked why, he told me that it was an old design and that it had been replaced by the Mate 2 and the Mate 3, and the people that had designed it no longer worked at Outback Power, and that they did not have any of the original design data for it, and there was no one at Outback Power that even knows how it works. He told me that I was on my own with it. A single string from the Outback Mate looks like this. It's an ASCII string with a lot of stuff that I did not need, so I stripped out what I didn't need, so the string now looks like this. And now I could parse out the data that I wanted. I started with the battery voltage, that's the 550 shown in the string, and once I knew that, I could then parse out the other data that I wanted. Once I had all the data fields that I wanted from the charge controller, I wrote the code that would let me display it on the Raspberry Pi's Python shell display. This is that data. As with the data from the EG4LL batteries, the next thing that I need to do is to display the charge controller data on a web page. Please check back for part 3 of my project Solar Cop, where I explain how I read and display the data from my Schneider Electric SW4048 inverter using the Modbus communications protocol on the Raspberry Pi. Please check back with the On My Workbench channel for more videos on cool stuff. Please subscribe, like, comment, share, and click the little bell. And thanks for watching the On My Workbench channel.